Hello students, welcome back to my channel Maths Insider. Today's topic is solving the problem on zeros of a polynomial. This is a very important topic where we'll deal with different problems, so watch till end. So what you will learn from this video is different type of problem that we're going to solve using zeros of a polynomial. So type 1, find 0 of each polynomials where we'll consider the linear polynomials. Then type 2, where we will verify the given zeros. So that means for any value of the variable x, whether the polynomial is 0 or not. Type 3, find all zeros for the quadratic expression or polynomial of form x square minus b square. Type 4, find zeros using the factorization method. Then type 5, find zeros using splitting the middle term. Type 6, graph based questions, and 7, value based questions. So these are all the important varieties of problem which we're going to solve. So let's start. Application of the zeros of polynomials. So we have learned what is zero of polynomials, and now we will try to apply it to solve different problems. So number 1, find the zeros. So here we will consider, this is the most simple problem going to come. Maybe it can come as an objective or MCQ problems. So we will be considering the linear polynomial. So here we will see px which is equal to 7x minus 2. It is a linear. So set px to 0, then 7x minus 2 is 0. So 7x is equal to 2. So x equal to 2 by 7. So it's very simple. This is the zeros of the polynomial. Now let's take another example. Find zeros for the given polynomial px equal to 4x plus 12. So what we need to do, the fundamental thing, we have to make the polynomial px to 0, then substitute 4x plus 12 which is equal to the 0, then we'll solve for it. So 4x equal to minus 12, x equal to minus 12 by 4, and it will become equal to minus 3. So this is the 0 of the polynomial. So is it simple? I think it's very simple. Let's go to the type 2 problems. So here we'll verify whether the given number is a 0 of the polynomial. That means, take an example, say a is equal to px which is equal to 3x plus 9 and x is equal to minus 3. So need to test whether the variable x minus 3 makes the polynomial equal to 0. So that is the main we need to verify. Solution, simple. We have to substitute the value of the variable x into the polynomial 3x plus 9. So therefore px is equal to 3x plus 9. We are putting the value of the variable minus 3 and we find minus 9 plus 9 gets 0. Hence we can verify that this polynomial is getting 0 for the value of x equal to minus 3. So minus 3 is a 0 of the polynomial. So hence proved. Let's take another example of similar kind. So here px is equal to x square plus 5x plus 6. For x equal to minus 2, we need to verify this or check this whether this is the zeros of the polynomial x equal to minus 2. So for this, what we need to do, we have to put the value of the variable minus 2 into the polynomial. So px is equal to x square plus 5x plus 6, putting x equal to minus 2. So p minus 2 is equal to minus 2 square plus 5 into minus 2 plus 6, which gives us 4 plus minus plus into minus becomes 10. So minus 10 and plus 6. So 4 plus 6 is 10. 10 minus 10 is equal to 0. So x is equal to minus 2, which is a 0 of the polynomial because we are getting px equal to 0. So these are the second kind of problem. Now let us take the third kind of problem, find all zeros of the polynomials of the form a square minus b square. So there will be more than one zeros. So that means it will be a quadratic form of polynomial. So let x square minus 9, let px is equal to a square minus 9. So it is taking the form of a square minus b square. So this is a quadratic polynomial as the highest power of the variable x is 2. So the degree of the polynomial is 2. Hence it is quadratic. Now, we all know from the formula of square minus b square, which can be expand as a plus b into a minus b. So if you see, x square minus 9 takes the similar form. So this can also be expand. It take the similar form of x square minus b square. So the polynomial px is equal to x square minus 9 can be expressed as follow: x square minus b square, which is x square minus 3 square. So x plus 3 into x minus 3, we can expand that. Now set px to 0, or x plus 3 into x minus 3 is 0. Therefore x plus 3 is 0 and also x minus 3 is 0. So x equal to minus 3 and x equal to plus 3. So we are getting two zeros of the given polynomial. What are they? So minus 3 and plus 3 are the zeros of the given polynomial. This is very simple. Now take another example, x square minus 25. So let px is equal to x square minus 25. Now we'll need to do the solve. We need to solve it. So x square minus 25 again takes the form of x square minus b square. So we can express x square minus 25 as a square minus 25 as a square minus 5 square. Now because 5 into 5 is 25, that can be expressed as x plus 5 into x minus 5. Now we'll set the polynomial px is equal to 0. So that means x plus 5 into x minus 5 is equal to 0, or x plus 5 is equal to 0 and x minus 5 equal to 0. Solving this, will get x equal to minus 5 and x equal to plus 5. So minus 5 and plus 5 are the two zeros of the given polynomial. So this is simple. So these are the third kind of problems which we are solving for zeros of the polynomial. Now let's take the fourth kind of problem, and these are now slowly getting little bit complex. I will not say complex, but little bit more we need to work on, like find the zeros by factorization. I think we have all done the factorization, but we are repeating here the concept while doing this particular type of problem. So px is equal to x square plus 5x plus 6. It is again a polynomial of degree 2 because the highest power is 2, and this is a quadratic polynomial. So for the above polynomial, we need to use the factorization. How we will do it? I think many of you already aware of how to factorize this kind of quadratic expression, but to simplify it, to again recollect what we have done in the previous classes or previous section, we can do it. So we have x square plus 5x plus 6. So 5 is a coefficient of variable x and plus 6 is the constant in this expression. Now rules to factorize this polynomial is: step 1, we have to first find all the factors of the constant, that is 6, and also check the sign of the constant, which is plus. So step 2, we have to express the coefficient, that is the coefficient of variable x. We have to express the coefficient as any two factors of the constant such that the product of those two number, with sign, with the given sign, will maintain the sign of the constant as well as the constant itself. What does this mean? So we have to and factorize the whole polynomial. So we will clarify this with this example. So what is happening? Let's take the above example. So we have px equal to x square plus 5x plus 6. So we are factorizing 6 to which are 2, 3 and 1. So these are all the factors and the 6 itself. So factors of 6 are 1, 2, 3 and 6 and sign is positive. So we are keeping these two in mind. Now in step 2 we have to express this coefficient 5 in terms of any two factors of 6. So like plus 5 can be written as plus 3 plus 2. So we can satisfy this. Also if we take the product of plus 3 and plus 2, it becomes plus 6. So it maintained both the product as well as the sign of the constant. So this is what we have discussed in step 2. Now factorize the whole polynomial. So it is very easy. We need to identify what are the factors we need to take to express the coefficients and also the sign. So let px equal to x square plus 5x plus 6. We have expand 5x as 3x plus 2x plus 3x plus 2x. So plus plus becomes plus and 3 into 2 becomes 6. So the sign is maintained, the product value is maintained. Now we can take x common from x square 3x and 2 common from 2x plus 6, which gives us x plus 3 and x plus 2. Now set px equal to 0 or x plus 3 into x minus 2 equal to 0 or x plus 3 is equal to 0 or x minus 3 equal to 0. Okay, sorry, my mistake, x minus 2. And what we are getting is that x equal to minus 3 and x equal to plus 2 are the zeros of the polynomial. Now let us take another example. Let take px equal to x square plus x minus 6. So let's use the factorization method. Use the factorization method to solve it. X square plus x minus 6. Again we are taking all the factors of 6, step 1, which are 2, 3, 1 and 6. Step 2, need to express plus 1 with any two factors of 6 which when multiplied gives minus 6. So 1 can be written as 3 minus 2 plus 3 minus 2 and plus 3 into minus 2, if we multiply we get minus 6. So it is satisfying. So we can factorize the above polynomial. X square plus 3x minus 2x minus 6. So this 3, 2, they have sign minus and plus. If we multiply minus 3 plus 3 into minus 2, we get minus 6. So it is satisfying the product, the constant. So then we are taking x as common, so become x plus 3 and minus 2 as common, then become x plus 3. So therefore x plus 3 and x minus 2, it becomes x plus 3 into x minus 2. So let now set px equal to 0. Therefore 3x x plus 3 x minus 2 is equal to 0, and solving this will get x equal to minus 3 and x equal to 2. So minus 3 and 2 are the zeros of the above polynomial. I think this is so simple. Okay, so I think that's great. Okay, so I have done some mistake here. It should be minus 2 and therefore the answer is given. Now let us take the fifth category of the problem. Find the zeros of the polynomial by splitting the middle term. So this is also, polynomial is also of the form quadratic, but the nature of this particular quadratic equation is little bit different from what we have seen in the type 3 category. So what is the main difference? It has another coefficient added apart from the coefficient of the variable x. It has another coefficient that is for x square. So this is a polynomial of degree 2, as the highest power of the variable x is 2. This is a quadratic polynomial. Before we solve this problem, we need to understand this expression and how to do the middle term. So now 3 is a constant, 7 is a coefficient, 2 is also a coefficient. So another coefficient is coming. So in the previous problem only one coefficient, but in this kind of problem there are two coefficients. So the nature is a little bit different. So how to deal with this kind of problem? Let's see. So we have to first split the middle term. The middle term means the middle coefficient of the polynomial. Split into two number with proper sign, so that the product of those two number will, the product of that constant and coefficient of x square. So that means we have to split the middle term or the coefficient in such a way that the product of those two will become the product of the constant and the other coefficient with a sign. So step 1, say product of constant x and coefficient of x square is equal to plus 3 into plus 2, which is equal to plus 6. Now step 2, split the middle term of x, that is coefficient of x plus 7, as plus 6 and plus 1. So we can able to express plus 7 as plus 6 plus 1. Now take the product of step 2. Now if I take the product of step 2, that is plus 6 and plus 1, it gives me plus 6. So the result of step 1 and result of step 3 becomes equal. Hence we can factorize this above polynomial. So now let's see how we can able to deal with this problem. So we have px equal to 2x square plus 7x plus 3. Now we are expressing 7x as 6x plus x. Now 2 and 3, 5 plus 2 and plus 3, if I multiply, it will gives 6 plus 6. And also if we expand 7 as plus 6 and plus 1, if we multiply this plus 6 into plus 1, this will also give me plus 6. Hence this is satisfying. So we can able to factorize it. So 2x square plus 6x plus x plus 3. So we taking 2x common, so x plus 3, and here we also get 1 common, x plus 3, which give me x plus 3 into 2x plus 1. Now we set px equal to 0. It will be very easy. We have already solved this kind of problem. Solve for the x, and we found to be x equal to minus 3 and x equal to minus half. So minus 3 and minus half are the zeros of this kind of polynomial. Now let's take another example. So px is equal to 6x square plus 11x plus 3, and let's step by step solve this polynomial. So step 1, product of the coefficient of x square and the constant, that is plus 6 into plus 3, which is equal to plus 18. Now step 2, express plus 11 into two terms, that is the coefficient of x, that is plus 11, into two terms, that is plus 9 and plus 2. So that makes plus 11 on one hand. And now product of these two terms, plus 9 and plus 2, will give me plus 18. Now in step 4, the result of step 1 and result of step 2 are equal. So they are satisfying. Hence we can able to do the factorization. So we can express 6x square plus 11x plus 3 as 6x square plus 9x plus 2x plus 3. Now plus 6 plus 3. If we take the product, it becomes plus 18. We are expanding 11 as plus 9 and plus 2. And if we multiply plus 9 and plus 2, this will give me again plus 18, which are same. So then we can able to factorize this polynomial. So 6x square plus 9x plus 2x plus 3, taking 3x common, 2x plus 3 and 1 common, 2x plus 3. So 2x plus 3 into 3x plus 1. This is factorized. Now set px to 0. Therefore 2x plus 3 and 3x plus 1, product of these two becomes 0. So 2x plus 3 is equal to 0 and 3x plus 1 equal to 0. So solving this, we get x equal to minus 3 by 2 and x will get minus 1 by 3. So hence minus 3 by 2 and minus 1 by 3 are zeros of the polynomial. So this is the fifth kind of problem, where we split the middle term and get the factors, and from that factors, when we make the polynomial px to 0, we can able to solve for x. Now the sixth kind of problem is graph based questions. These are very easy, just we need to be very careful and understand the concept of the graph and relation of the graph with the polynomial, then we can easily find out. Now the question comes like this: without drawing graph, state the number of zeros. So let's take example 1 or A. Graph touches x-axis at one point. Solution: you can just do a rough work. So if I take a straight line is touching only the x-axis, so it has only 1 zeros because it is only touching the x-axis at one point. So this shows there is only 1 zero for it. Mainly it will happen for the linear polynomial. Now second, graph touches or cut the x-axis at two distinct points. So solution: this kind of graph are mainly quadratic form of graph, which is curved in nature. Only then it will cut the 2 points in the x-axis. So from this we can easily make it out, or it can be shown that there are 2 zeros for it. So answer is 2. Now let's go to C. So graph does not meet the x-axis at all. Okay, solution: so that means it is a curve, or it is the polynomial will have a kind of curve which never touches the x-axis. So if it does not touch its x-axis, there will be no zeros for the given value of x. So that means there are 0 zeros for the given polynomial. D. A straight line that cuts the x-axis once. Again, this is similar like A. We are drawing the graph, so it is cutting at one point on the x-axis. So here number of zeros is 1. It's very simple. So this can be coming in MCQ or in the objective based questions. Now E. A constant polynomial of nature y equal to x, that is equal to px. So px is equal to 5. That is a constant polynomial, as we have discussed earlier from the base. So that means it is a line which will be parallel to x-axis and it will never meets the x-axis at all. So as it will not cut x-axis, the number of zeros of the given polynomial is 0. So answer will be 0. So this is the sixth type of problems, which is the graph based problem. Now we are moving to the last category, which is the finding the value based question. So it's a value based question. It's very easy. Just follow the process and you can able to solve it. So if 2 is a 0 of the polynomial, so that means if x takes the value of 2, the polynomial will become equal to 0. Now in that polynomial there will be an unknown value k. We need to find that. So x square plus kx minus 6 is that polynomial where k is unknown. So find the value of k. Solution: as 2 is a 0, so let px equal to x square plus kx minus 6, put x equal to 2, and we get 2 square plus 2k minus 6, putting p x equal to 0 for x equal to 2, and now we are solving for the given equation. 4 plus 2k minus 6, so 2k minus 2 equal to 0, so k equal to 2 by 2, which is 1. So value of k is 1. So this is the value based kind of questions. Now number B, if 5 is a 0 of the polynomial, so x square minus 9x plus k, find k. So here also if we solve it, let's px equal to x square minus 9x plus k, putting the value of x as 5. So p5 is equal to 5 square minus 9 into 5 plus k. Now since p5 is equal to 0 at x equal to 5, so we are solving for this equation, and we will get 25 minus 45 plus k, is minus 20 plus k, and k is equal to 20. So these are different type of problems. I hope you like it. So subscribe to the channel, share with your friends. See you in the next video. Thank you.